Okay, guys, this next lecture is going to be electron configuration examples, primary topic, with a little bit of added in information here and there. Keep in mind something I want you to review, and I will show you this, but I won't go into great detail on how it works. It's the noble gas shorthand and the periodic table and the structure of the electron configuration. Okay, let's dive into just electron configurations and look at them progressing along the periodic table. Now, if you have a periodic table in front of you, which you should have one, I hope, print one out for yourselves now if you haven't already. Start getting familiar with it. Hydrogen has one electron, because remember that for neutral, this is something we should mention back here, for neutral atoms that are not any sort of total charge, neutral atoms, as you'll have seen in the book, will have the number of electrons will be equal to the number of protons, so that the charge is balanced. Of course, you also have ions, which is another topic we will talk about soon, where the number of electrons is not equal to the number of protons. You can have ones where the number of protons is higher than the number of electrons, you pulled some electrons off, or you can add more electrons where the electrons are higher in number than the protons. That'll give you a positively charged ion versus a negatively charged ion in those two examples. Now, we don't want to talk about that right now. Let's move back to electron configurations. These are neutral atoms that we're looking at right now. Let me specify that. These are neutral atom configurations. We will look also at ions, but hydrogen has the N is 1, the subshell within that 1 first energy level is only an S, and there's only 1 electron on that hydrogen, so it's 1s1. Helium has a second electron to balance its neutral atom with the 2 protons in that nucleus. So you've got an N of 1, a subshell S, and now 2 electrons in that subshell. The next, of course, is lithium, and now we've got 1s2, and now since lithium has not 2 electrons but 3 electrons, we have to go up to the next N value of 2. The first subshell within that N is S, and we put our first electron there. Continuing on, as the book shows you, you can see beryllium, of course, will be 1s2, 2s2. Now, let's jump up a little bit here. Let's jump over to fluorine. Fluorine has 1s2, 2s2. Now, how many electrons does fluorine have? Fluorine has in its neutral atom 9 electrons. We've used, here you can see this is 4 electrons so far. So the next subshell within the value, N value, the primary energy level 2, is a p subshell, which means we've got 5 electrons left, and those 5 electrons can go in there. Because remember that p subshells can hold 5 electrons. S subshells hold 2, p hold 5, d hold 10, and F hold 14. Okay, now let's look at an example of one that finally reaches a possible shorthand. As you may have read in your book, you can utilize the shorthand of the electron configuration up to a noble gas. So let's do the longhand first. Let's do potassium. Potassium longhand, if you go through with me, is 1s2, 2s2, 2p6. Okay, good so far. Now we have a bunch more electrons to use. We're now down into the third energy level. Its first subshell is S, so 3s2. Going across, then we now fill 3p6. Now, read up on how to utilize the periodic table and how it works, and I'll put an image in here of these notes as well to show you. The next subshell we'd actually be hitting is the 4s subshell before the 3d. We get to the 4s. We put into 4s, we have only 1 electron left, so we put 1 electron there. Okay, and we'll talk about that a little bit more after this. Let's look at how you do the shorthand. Now, if you look at this electron configuration, up to the point where you hit 3p6, that electron configuration This bit right here within this electron configuration is the electron configuration of a noble gas. And if you look at your periodic table, you'd see that this is argon. So therefore, we can shorthand this to bracket argon, representing that stuff that's argon, and just put everything after it that does not belong to that noble gas, 4s1. Okay, good so far. Let's stop this lecture here, and we will come to the next lecture to look at the periodic table and talk briefly about how that fits in with electron configuration.